Mona, are you right for me right to start?
Yes, please.
Thank you. Good afternoon, everyone, and thank you very much for coming. It is traditional, of course, to start with an acknowledgement of country, and we'd like to thank the Indigenous First Peoples for their custodianship of the lands and waterways in which we are visiting, especially today on Camaragal country. And we'd like to thank the elders, past and present, for their ongoing wisdom and guidance and knowledge. And so, welcome everyone today to Mona's final year review. And I'd like to welcome her milestone panel with the expert panelists of Associate Professor Keong Yap and Dr. Hairan Zhang and Chair Professor Joseph Sirachi. And Mona's PhD panel is Associate Professor Jesse Gao as the principal and co-supervisors Professor Herb Marsh, Associate Professor Teresa Dickey and Professor Reinhard Pekran. And so now I'd like to hand over to Mona, and I would like to ask everyone else to please go on mute until we go to the Q&A. Thank you.
Thank you, Ricky. Hello, everyone. Thank you for joining me today. I'm here to share my final year review presentation. My research revolves around understanding the relationship between academic anxiety and academic performance, particularly focusing on any nonlinearity. Let's get started with the idea came from. Traditionally, researchers believe that there is a linear relationship between test anxiety and academic achievement. However, the relationship between these variables is not that linear as we thought. The Yerkes-Dodson law suggested that there is an optimal level of arousal for maximum performance. This means increased arousal can enhance performance, but up to a certain point. At that point, when arousal becomes more excessive, performance diminishes. So, this curved linear relationship between arousal and performance has more support in the athletic setting, which suggested that athletes do better when they feel more arousal, following Yerkes-Dodson law. But when it comes to the educational setting, there are a few research which investigated it. So there was a big gap in the literature, which made us to still question the nature of this relationship. And why is that important to answer this question? Imagine if anxiety can enhance performance by motivating students, and if there is an optimal level of anxiety that can vary from for each student. So it means we need to change our policies, our strategies in terms of helping students to find their own optimal level of anxiety to have a better performance. So this is just a reason. Also, it can have a bigger effect in terms of policy setting. For example, students and educational institutions should create individual program to help students understand and manage their own anxiety levels. So, this reason made us have a comprehensive exploration of the relationship between anxiety and academic performance. So, my PhD thesis aimed to explore the relationship between these variables by focus on any potential nonlinearity. Specifically, I was interested in whether there is a threshold at which test anxiety become more excessive, performance diminishes. To address this, my research includes two comprehensive studies. In the first study, I investigate the nonlinear relationship between test anxiety and academic achievement from a cross-cultural perspective. And in the second study, I examine the nonlinear relationship between these variables from a within-person perspective. So, the first study of my PhD examined whether a nonlinear relationship exists between test anxiety and academic performance, while also exploring how this relationship varies across different cultures and countries. To address this, I did a cross sectional multi level regression to analyze my data. I used three different databases, as you can see by the slide, as each one of them provided unique characteristics for me. Also, as you can see, these databases include different countries, and the sample size combined in about 785,000 students. So here, I don't want to repeat my results from the study one, as I mentioned in my mid candidature. So let me just have a brief review of what we got. As you can see from the figures presented here, there is no evidence for nonlinearity in relationship between these variables. And also, both linear and nonlinear models consistently show a negative relationship between test anxiety and academic achievement. Furthermore, this negative relationship between test anxiety and academic performance was consistent across different countries and age groups. So you might be thinking, okay, there is no nonlinear relationship between these variables. Should we just stop here, or we need more analysis? Actually, we didn't stop here. And you may wonder why we keep analyzing when you already get the results. The answer is simple. Statistically, covariances between variables at the um, between a person level when you are doing comparison across different individuals, and covariances between variables at a within person level when you are doing comparison over time for the same individual are typically considered different. So also building on Yerkes-Dodson theory, which says that there is an optimal level of arousal for maximum performance, it is proposed that an optimal level of anxiety may vary among individuals. This optimal level of anxiety could influence performance differently across individuals. So this led us to employ both between and within person approaches to figure out if there is any nonlinearity based on within person differences. We also hypothesized that performance and anxiety are reciprocally linked, meaning that changes in one are associated with changes in other ones. So this reason made us use cross-leg panel model and random intercept cross-leg panel model. As CLPM allows me to explore how anxiety and achievement influence each other over time, it helps determine whether anxiety at one point affects further performance and vice versa. And second, since I'm focused on whether the relationship is linear or nonlinear, CLPM enables me to test both possibilities. And next, RI is crucial for my study because it allows me to separate within person changes from between person changes. So this gives me a clear picture of how anxiety impacts each individual performance over time beyond the general trend. Additionally, I explored how individual characteristics influence both within person changes and between person changes in the reciprocal relationship. So here my first research question is when students have higher math anxiety than the others, are they are more likely to see a drop in their math achievement over time? And is this linear or is this nonlinear? And similarly, when students achieve better results than the others, are they more likely to see a reduction in their math anxiety over time? And the second research questions focus on within person approaches, asking when a student experience higher than usual math anxiety compared to their own long-term average anxiety, are they more likely to experience a subsequent lower than usual achievement compared to the long-term average? And is this relationship nonlinear? And similarly, when students achieve higher than usual results compared to their own long-term average, are they more likely to experience a subsequent decrease in their anxiety level? Additionally, I explored how this relationship evolves across various subgroups by considering moderating variables such as age, gender, socioeconomic status, and self-beliefs. So by using the longitudinal data, this study captured a more dynamic understanding of the relationship between these variables. So here you can see my data set. I use Palma data, which is a longitudinal study gathered based on German students from grade 5 to 9. Each year, assessment includes surveys from students, teachers, and parents, alongside with math tests, school grades, and school records. Here you can see my variables and measurements. I used two different measures for performance, school grades and test scores. School grades are the yearly assessment done by schools, and test scores came from PALMA Math Achievement Test, which measures broader math competencies. And a student's anxiety in mathematics has been assessed by using achievement emotion questionnaire. As you can see, this questionnaire has three different subscales, totally 15 items. So as I mentioned in the previous slide, in my study, my questionnaire includes three different factors. To figure out if these subscales are distinct from each other, I ran a confirmatory factor analysis. As you can see, these factors are highly correlated, so we disregard using these subscales in favor of simplifying the analysis. So I combine them as a one construct called overall math anxiety. And here you can see my method. I use cross-leg panel model and random intercept cross-leg panel model to analyze my data. Table 2 presents the mean standard deviations and correlation among math anxiety, school grades, and test scores across all waves. Math anxiety showed moderate positive correlation over time, indicating that anxiety levels remain stable. Both math grade and test score here showed a strong positive correlation as well, suggesting that high stability in academic performance over time. And the table also highlighted a consistent negative relationship variables, showing that the higher anxiety is linked to lower performance. So, as I mentioned before, for the research question one, I use a cross-leg panel model. I examined both linear and nonlinear models to see if anxiety has a consistent effect. So here I'm gonna explain briefly the process of evaluating and improving my statistical model. Here's is a breakdown. So I start with the M1. Initial model assume a linear relationship between math anxiety and test scores. However, based on the fit, it doesn't represent a good fit for the data. As you can see, the root mean is high. So M2 shows an improved fit by adding a leg to effect. As you can see, the model fit improved. And in the next step, all regression passes are constrained to be equal in M3. I tested for invariance to figure out whether the relationship between my variables remain stable. Then I repeat all of analysis for the nonlinear model. So here you can see the diagram for the model. This slide helps us to have a better vision of the model. So here you can see that the model includes data across 5 time points. The autoregressive passes demonstrate the stability of both anxiety and school grades over time. As you can see, for math anxiety is 0.55 and for the grade is 0.52, indicating the high stability across time points. And the cross-leg passes illustrate how these variables influence each other. For example, the blue arrows represent the effect of anxiety on further performance with the coefficient of minus 0.062, showing that the higher math anxiety at time 1 predict lower performance at time 2. And similarly, the orange arrows shows that the effect of performance on further anxiety. The pass coefficient is minus 0.05, suggests that better performance leads to reduction in anxiety at subsequent time points. And the green ones at the bottom represent the quadratic effect, which is not significant, which is significant here. So overall, this model demonstrates the reciprocal relationship between variables where increased anxiety tends to lower performance and improved performance reduce anxiety at the next time. The stability of both variables is strong and the model captured how these influence each other over time. And also, I added the leg 2 effect for anxiety based on Heard Study 28. By including the leg 2 effect in my model, I'm considering not only just the effect for the test anxiety from the previous year, but also from 2 years earlier. So basically, I'm essentially increasing the model's ability to manage change in unmeasured covariances. So here, this is a model for a math anxiety and test score, which is pretty similar with the previous one. So I disregard to explain this one. So I answered my second research question by using random intercept cross-leg panel model. So here you can see the figure shows the random intercept cross-leg panel model, which I use to examine the relationship between my variables over time. It allows me to separate within percent changes from between percent differences. The circles labeled here RI anxiety and RI achievement represent the random intercepts which capture the stable differences between students. This shows how much variation in math anxiety and performance is due to individual differences that remain consistent over time. And within person effects are shown in the ovals, such as W anxiety and W achievement. These represent how anxiety and achievement fluctuate within individuals over time. For example, the pass for W anxiety at time 1 and W anxiety at time 2 shows the stability of within person anxiety, meaning that an individual's anxiety levels remain fairly consistent over time. Also, this model shows how these variables influence each other. For example, the pass from W anxiety time 1 to W anxiety time 2 has a coefficient of minus 0.079, showing that higher than usual anxiety leads to lower performance at the next time point. Similarly, better than usual performance is associated with the reduction in further anxiety. So here you can see this model for test score and mass anxiety, which is pretty similar with the previous one. So to address research question 3, I focus on how individual characteristics such as gender, SES, self-concept, and self-efficacy influence the non-linear relationship between these variables. So I disregard presenting my tables to save my time. Based on this graph, you can see there is no interaction for gender over time. And similarly, based on this graph, you can see there is no interaction for SES over time. And this table provides insight into how academic self-concept influence the relationship between my variables in terms of main factor effects. Math anxiety has a significant negative effect on both math grade and test score. This suggested that the higher level of math anxiety are associated with lower performance, and the quadratic term of math anxiety is marginally significant for test score, but not for math grade. It suggests that low level of anxiety have little effect on performance, but as anxiety increases, higher level of anxiety have an accelerating negative impact on performance. And also self-concept is positively associated with both performance. This indicates that a higher academic self-concept leads to better performance. And there is a significant interaction between linear term of math anxiety and self-concept for test score, suggesting that self-concept moderate the relationship between my variables. So as you can see, based on this graph, there is a small but important interaction between anxiety and self-concept on test score. When anxiety is low, having a higher self-concept helps reduce its negative impact. However, as anxiety increases, this protective effect diminishes. So based on this graph, there is no significant interaction based on relationship between anxiety and math grade. And here you can see the moderating role of self-efficacy, which is not significant for both math grade and school grade. So, to summarize the key finding of the study, first, we identified a reciprocal relationship between anxiety and performance. This means that anxiety and performance influence each other over time. Second, the study found no evidence of a nonlinear relationship between these variables. And lastly, we observed limited moderation effects from variables like gender, SES, and self-efficacy. However, one notable exception was self-concept, which slightly buffered the relationship between these variables, especially when the level of anxiety is low. So here you can see several key implications can be drawn by my study. Based on the reciprocal relationship between these variables, this underscores the importance of intervention program to break down the cycle. And next, we found no evidence of nonlinear relationship. This means the mass anxiety's negative impact on performance remains steady across different anxiety levels, suggesting that teachers should enhance coping skills for students. And lastly, based on the buffering effect of self-concept was found, suggesting that enhancing a student's self-concept could be particularly effective for those with lower level of anxiety. So here you can see suggestion for the future research. First, we should focus on more on academic self-concept as a moderator, investigating how a strong self-concept can further reduce anxiety, especially at higher levels, could provide valuable insight to designing effective interventions. Second, since our study focused on no evidence for optimal level of anxiety, which means anxiety is totally negative for performance, it emphasizes the need of construct intervention studies aimed to reducing anxiety levels. And lastly, we should explore other potential moderation, like maybe something like um, uh, personality traits or teaching styles could provide a new approaches on how the relationship between variables is influenced. So for the next step, I'm gonna work on my write up my thesis during upcoming 6 months. Before I conclude that, I would like to take a moment to express my heartfelt thanks to all of my supervisors who had supported me throughout my PhD journey. And a special thanks for Jessie, my prime supervisor, for your continued support and insight. All PhD students know that it's a very interesting and challenging journey, but it definitely got easier with your all support. Thank you. Thank you.
Well done, Mona. Thank you very much. Joseph, can I hand over to you?
Sure. We'll start with questions from the floor. Does anybody have any questions for Mona?
Can I go first?
Sure.
Yeah. I have a couple of questions. First out, thanks, Mona. Your hard work and good presentation, and I was really enjoying your older work. But I have I have a couple of questions, and this time I'm gonna just give it very just the fundamental questions to you. The first one is so actually your main research question was to test either linear model or non-linear model relationship between the anxiety and academic achievement. But actually your research the findings did not support non-linear model. So I think this is a very important point of your research. Then I'm wonder your interpretation, why your data, your study didn't support non-linear model, which is the contradicted findings from the contradicted findings of previous research. What is your interpretation? This is my first question.
Am I right? Like you are asking one, we have like previous studies found nonlinear relationship and we didn't. Are you asking this?
Yes. When you develop this research question, you
Yeah.
hypothesize that you hypothesize
Yeah.
that there would be quadratic relations,
Yeah.
and also the supported empirical research findings and theoretical framework. But
Yeah.
it's not. You tested hypothesis with such a big data set, but it didn't support. And what is your interpretation? Why you didn't find it? Yeah.
Actually, I'm not sure that I get it right. So you're asking why I didn't found it. What do you mean of it? You mean the nonlinear effect?
Yes, your psychological
Yeah. Based on
explanation.
Yeah, based on when we start searching about this nonlinearity, we found lots of support in terms of atlas setting. And when it comes to the educational setting, we couldn't find too many. There was like 7 articles, and 4 of them was too weak, so I removed them and just remained 3 studies, which investigate, okay, there is a nonlinear relationship in academic setting. So we think, okay, maybe we can find a threshold for each student. So we design our study based on this. But we couldn't find any. Um, and I think this result is contrast with the atlas setting, and I think for atlas is makes sense because when they feel arousal and they feel like activation in sympathetic response, they do better because they don't need to use the memory or cognition process to solve the problems. But when it comes to the educational setting, it goes difficult because anxiety can disturb your concentration. So we thought maybe this anxiety is positive and it can motivate students to do better. I clearly remember that when I was in high school, our teachers encouraged us to compete each other. At that moment, I thought, okay, this is good. We are competing each other. And they put us into pressure to compete and do better. But now, based on this study, we found out this anxiety is disturbing. So, yeah. Did I answered your question?
Yeah, thank you. I remember your your writing that says probably depending on the level of test.
Yeah.
That might impact on the relations. So I remember that one. So
yeah.
I think
that's
the
why we
important.
use that's why we use mathematics as a subject. You know, in a study 1, I had different independent variable. So for the final one, we use Palma as is a high task to do for a student because it's difficult to a student to doing mathematics. Based on Kelly research, yes, in high task there is a curvilinear relationship, but we couldn't find any support.
My next question is so also I remember you in your writing the Reinhardt already probably he has shown the relationship between these two, the reciprocal relations. Then you didn't find he already has shown the relations.
But he didn't investigate the nonlinear effect. His study basically based on the linear relationship. So the novelty of our research is we focus on nonlinear relationship and reciprocal relationship between these variables.
Okay. Then okay. So based on your findings, whatever it is, then what is the what's new, and what is your contribution to the field?
What is the new?
Yes.
You mean the results?
You find it and contribution to the field?
Yeah, I think the main finding and important finding for my research is that there is no nonlinear relationship between these variables, which means anxiety is totally negative for performance. It means students, teachers, policymakers should know that, and they have to change their policies to reduce the level of anxiety for students. There is no motivating anxiety. There is no optimal level of anxiety. So I think in terms of uh, educational setting, we need to change our policies to help students to do better without feeling anxious, without feeling nervous. So, and the second finding could be in terms of the moderating role of self-concept. When the anxiety levels is low, self-concept has like a moderating effect, which is good. But when it goes up, it doesn't help anxiety at all.
Thank you. So can I give one more?
Sure.
Yeah. So your interesting finding is the moderation effect of self-concept. But however, the self-efficacy did not show moderation effect.
Yeah.
Can you interpret why?
Yeah. Self-efficacy is basically means it defined as in terms of your ability. But self-concept is a broader context. It's about the way you are like validate yourself. So it's connected with your worth. So as we saw based on my research, when we investigate the within person differences and between person differences, so it's interesting because we found that, okay, anxiety is a stable trait. When a student at the like first class feel anxiety, he will feel this anxiety in the upper years, like in further years. So we know that. And also they have a reciprocal relationship. So if students feel like bad in mathematics, based on his performance, so these students have a lower self-efficacy. But that students, if have a good feeling about himself, like I'm capable enough to solve this problem, I'm capable enough to like learn mathematics, which based on self-efficacy, I think it can help. So yeah.
Okay, thank you.
Thank you.
Okay, other people? Do other people have questions? Chloe?
Yeah, hi. Thanks, Mona, for your
Hi.
presentation. It was really interesting. I just had a quick question, really. I was curious about how you are defining arousal and anxiety, because in the opening slides, it sounded like you were using those terms interchangeably, but I would have assumed they meant different things.
Yeah, thank you. It's a nice question. It's an interesting question because anxiety, arousal, basically, Yerkes Dodson law is basically on arousal levels. So arousal is one dimension of anxiety. Anxiety as an emotion have 5 different dimensions. So in based on physiological dimensions, arousal is one part of anxiety. So anxiety is a bigger umbrella and arousal is a one part of it.
Right. Yeah, that makes sense. Because I could see how in the context of sport, how that level of a level of arousal would be helpful in terms of being primed for the event, whereas can see how in the context of, maths, having those negative, views or, thoughts of impending failure, in that sort of sense would not be so helpful. So yeah, that's interesting. Thanks.
Okay, I might ask a question then, if I might. First of all, why is it necessary to do a cross-like panel model if you've done the random intercept cross-like panel model? What additional information do you think you get from the first model?
Actually, it's an interesting question. For me, when I experienced working with these models, for me at the beginning was learning these statistics because this complexity is difficult when you just jump in the cross-leg panel models in terms of learning. So I can understand because I'm at the end of my tunnel. So I start with regression, multi-level regression. Then I went to the cross-leg panel model and RI random intercept cross-leg panel models. And I think in terms of variation, it could be different because one of the benefit of cross-leg panel models is variation between individuals, but RI cross-leg panel models just focus on within person variances and between person variances. So we might miss some of these variations based on just focusing on RI.
Okay. I'd be curious to try and understand that a bit more. But the other thing I was thinking is you have 5 waves in your second study, don't you?
Yeah.
Did you do, and I saw you use multi-level modeling, did you test random slopes between anxiety and performance? So in other words, so you've got an estimate of the link between anxiety and performance.
Yeah.
And a significant random slope would mean that that estimate varied from person to person to a significant amount. So what I'm curious about is how many people does that relationship apply to in the sample?
Yeah, Joseph, probably like I can answer this a bit basically because it's more technical things like because the multi-level one, we try to mirror what we did for the random cross-lab panel model, the RI cross-lab panel model. So the random intercept model, the RI one is basically just only have a random intercept. So we mirror that one. But that's an interesting point. Probably we can do further a little bit random the slope of the self-concept to see whether the the effect value as a function of individual or not.
Yeah, I mean, it's not a criticism at all. It's just another way of kind of further. It's pretty simple to do. You just add random slopes, and then you can characterize the range of. In other words, you could think of it as a distribution of effects of anxiety on people. So for some kids, maybe there is a nonlinear effect of anxiety. For others, there isn't. Like, it would be exploratory, but it would still be provocative to say, well, actually, for 10% of these kids, there was a significant quadratic effect. I don't know if you'll get it with only 5 points, though, but at the very least, you'll see it'll probably be significant. And you'll see for some kids, anxiety had a huge effect, and for others, it had a smaller effect. But with only 5 points, you won't be able to say much more than that, other than that might be an interesting future direction.
Yeah, I agree.
But excellent, fantastic, and very impressive presentation. Amazing level of statistical knowledge. The things I'm asking now is because you're so far out there that, this is like right on the cutting edge, these kinds of questions.
Thank you.
I have a couple of questions. First of all, well done, Mona. Really nice presentation showing how you are taken a research question and you delved into it, kind of unpacked and focused on one question and answer it thoroughly. So well done. It's good to see all the studies laid out the way you've laid it out. I've got a couple. This is the fact that you did not find a non-linear. That's a double negative. I'm trying to wrap my head around that. You did not find a non-linear relationship. I think that's significant. You're right. When I talk to some of my kids, I'm thinking, oh, some anxiety is okay. Don't worry about it. But what you're saying here, based on your findings, is there's no space, there's no place for anxiety. Sometimes there have been discussions about different cultures and different ways of thinking. You mentioned earlier on that there was some you did add culture as one of the moderators. I saw some indication of that. Am I right to assume that was not a moderator as well in your findings?
Actually, in the first study, my focus was different countries. So different countries with comes with different cultures as well. So we assume that they have different cultures. But interestingly, we couldn't find any non-linearity for any of them. So anxiety means it's totally negative element for performance. But interestingly, because it might be helpful in terms of other personality traits, but when it comes to the anxiety, it can disturb performance.
And I think your explanation with regards to mathematics being something that involves a lot of, it's not a physical activity like sport. You have to think a lot, and anxiety can impede on it. One thing I'm wondering about also is the idea of anxiety as a state as opposed to anxiety as a trait. And you've described your measure as a trait measure. It's quite stable across time. And I'm wondering if you can, maybe in your discussion, add on a little bit more about a limitation, I think, in your study that you have not measured anxiety as a state. And I wonder whether this Yerkes-Dodson law applies at a state level, when you go in and you're feeling a little bit anxious, that actually might be helpful. Any comments about that?
Oh,
Thank you. Yeah, I wrote it. Yeah, I will work on it in my discussion session, and definitely is a good idea. Thank you.
Now, overall,
I think that's
a
great point, actually. Let me just add to that. I thought that's so good, Kyung. Like the possibility that because you've got like a year lag, the possibility that to get this nonlinear effects, you need to do maybe more experience sampling study. I think that would be a great discussion point. In other words, shorten the lag so that it's like, how anxious are you feeling right now? Not like how anxious do you generally feel, because then you're predicting a year later.
Yeah.
Any other questions?
Not for me. Well done.
Thank you. Okay, if there's no further questions, I think we can wrap this up. Thank you very much to everyone. Can you please give another online round of applause for Mona?
Thank you.
So well done, Mona. So from this point onwards, I am just going to switch off recording subscribe so I don't get myself into trouble again.